Let's start topic 7, okay, on decision trees and ensemble methods. Okay, on in the first page, we'll more or less have this contents on the software packages, okay, which is supporting decision trees and ensemble methods. Okay, so for R we have quite a few listed here, but in our practical class we'll be using only 3, and the other one is this thing called R part, which stands for recursive partitioning. Okay, and for the ensemble methods, we are going to touch only on the random forest. Okay, and okay, the generalized boosting methods. Okay, so okay, Python also has 3 decision tree methods, okay, which is supported in this module, sklearn3. Okay, we have 2 types of decision tree. Okay, this classifier and regressor. Okay, and for ensemble methods, it's actually all organized under sklearn ensemble. Okay, then we proceed to the section 7.1 about decision trees. So what are decision trees? So the key thing about decision tree, you can think of it as a real world tree being put upside down, where we actually have a root, okay, and under root and the so-called leaf nodes, we have something called a decision node. Okay, starting from the root. Okay, so best thing to look at it is a picture, right? Okay, so you can actually see the root node here, and then we have all the internal nodes, and all these the leaves are the last nodes. Okay, for numerical features, we actually discover that decision tree is actually related to the so-called partition regions. Okay, so down here you actually find the partition of the iris data set, which is something default in R. You can just call iris and you would have iris data set. Okay, we're not going to go into the detailed analysis of how to perform partitioning, okay, for numerical values. We are only going to discuss something simple, okay, table with only categorical data. Okay, so this playing tennis data is quite popular, okay, well known in decision tree example. Okay, so later on we will have the tutorial, okay, examples explaining on how to use the ID3 methods to build up a decision tree. Okay, so an example of decision tree for the thing just now is it looks like this. Okay, you can see the features, outload, humidity, wind, okay, all being encoded, and the leaves are the response variable. Okay, just going back to the table, you can see outload, humidity, wind, and the last one is actually play or no play. Okay, so apparently the temperature is not that important. Okay, that actually just depends on the decision tree. Okay, it will okay, we will have a special algorithm to actually build it up. Okay, so so how do we actually build a decision tree, okay, the key thing is actually to set up the purity in the leaves. Okay, purity basically refers to the case where we have the a node before the leaf where we know the output is all the same. Okay, something pure, either yes or no. Okay, so down here we just mentioned about again the predictive regressors. Okay, just now we have already seen that it's related to the partitioning. Okay, so this is just to emphasize it again, and the tutorial basically is to tell you true examples how they are related to each other. Okay, so I think this is something where okay, part of the answer is actually given. Okay, for SOA exam, you'll find that they're mostly multiple choice questions. Okay, where we're given this, and then you just have to see which one of them is actually true. Okay, and then you just choose the right one. Okay, so yeah, I mean, since the answer is given, I'll just skip this part. Okay, page 171, okay, section 7.2, it's all about how to choose the predictor. Okay, and then after we're chosen, then we need to know how to split the data, right? Okay, so you'll find that in the paragraphs I mentioned about some of the splitting criteria actually depends on the predictor, because if it's qualitative or categorical, okay, we would more or less just class them, okay, depending on the category. Okay, so meaning if you have A, B, okay, we just put two A's together, two B's together. Okay, if it's quantitative or numerical, then we can't do that, right? Okay, then we need to start to set up the range. Okay, that's you can see here, set up the range. So okay, depending on the predictor, okay, again, if it's qualitative, then normally you have two choices, okay, on how to split them. Okay, you can split them into two, or you can split them based on the category. Okay, just to go up a bit. Okay, let's look at this thing. Okay, so for instance, you see Outlook has sunny, outcast, and rain, right? Okay, so basically, if we actually have three categories for Outlook, then one possibility is split into three. Okay, so three subsets. Okay, that's how we will be doing it. Okay, in this so-called multi-way split technique. Okay. Okay, but then there's a question. Which predictor should we select? Okay, so basically the predictor selection needs something like measuring it. Okay, a kind of measure where okay, we calculate the information of this, and then for each of the predictors or features, okay, and we find that oh, this one is giving us the largest or smallest value, okay, indicating that okay, this one is the best to split. Okay, so there are many different kinds of measures, okay, relating to this. Well-known examples are information gain, okay, it's related to entropy. Okay, so this subsection basically is on entropy and information gain. Okay, so part of the answers are given, and then you should try out on how to perform calculation for other splits. Okay, so then what else? Information gain has a problem of favoring predictors with large number of values. Okay, this is bad. Why is it bad? Because think about the splitting of the tree. You have too many splits. It's going to make the tree large. Okay, because you have many choices. Right? You try to reduce the number of choices you have in the tree. Okay, so how can we improve on this? The way to improve is to use something called gain ratio. Okay, then in order to find the gain ratio, we need to find intrinsic information together with the previous information gain. Okay, then okay, we can calculate the gain ratio. Okay, this gain ratio with some examples, and next we were going to discuss is Gini impurity index. It's not the same as Gini coefficient, which is well known in economics. Okay, this is something else. Gini index. So here it tells us that when the partitioning is pure, okay, we will actually get 0. Okay, if it's not totally not pure, okay, meaning everything has equal chance, meaning okay, we don't know which is the more important things, right? Okay, so then is the more category we have, meaning the closer it is to the value of 1. Okay, and then it's some examples on and past year exam questions on the definitions, calculations. Okay, so as I also took sample examples from SOA SRM exam question and put it here. Okay, you can roughly take a look at them. Okay, so then we'll proceed to section 7.3.